So we found the value of t here is b h bar square over 2m, and we will find the value of v now. So to write v here, this is psi v psi, and this thing is equal to the function I will write. So it will come out to be, this is half m omega square will come out because this is not a derivative operator now. So I have half m omega square, this will come out, and then a here and a with the other side, so it will come out to be a mod square, and then integration from minus infinity to plus, and I will have the x square of this one, the x square here, and then e to the power, the 2e exponential will multiply, and minus b x square dx. And this thing I have already found that this thing, this integration comes out to be half for, because this is minus infinity to plus infinity, and 1 over 2b is, I have written the cube form in this one, and this the square root. So the result we have already derived in the previous calculation. So we have this equal to this, and so v comes out to be half m omega squared, and then what about a squared? A squared will come out to be 2b over pi, 2b over pi, and this is 1 over 4, so it will come out to be 1 over 2, and then half 1 over 2b and pi over 2b here. So we are having some cancellation, and this is 2b over pi is gone with pi over 2b, and then we are having 1 over 2, 1 over 2, and 1 over 2 will become 1 over 8 m omega square over 8b. So this implies that the expectation value comes out to be m omega square over 8b. And so we have found the v as well. So this implies that h, first I will write the t value, the expectation value of t, so b h bar square over 2m plus m omega square over 8b. This is the value of h, and this value is supposed to be greater or equal to the ground state energy. This is an upper bound for this. For any value of b, because here m, the mass, the frequency of the oscillator, only b is a parameter that which will determine the h value. So now, is this h is coming out to be equal or greater than EGS? So we can minimize this thing. We can minimize the value of h in order to go to the minimum possible value of energy. So I can write that we will have to minimize this h value with respect to b, and this will be d over db. We are minimizing with b and h, and the first derivative is supposed to be equal to 0 for the minimum value. So this will come out to be, if I derivate this thing h with respect to b, then here it will b will become 1 and h bar square over 2m is here, and plus this will be 1 over b, so 1 over b will become minus 1 over b square. So I will have m omega square over minus 8b squared, and this is equal to 0. And further I can write that m omega square over 8b square is equal to h bar square over 2m, and some simplification, 2 is gone with this, so 4 here, and then I will multiply this, and this is a cross multiplication, and I can write b in terms of this. So what b square will be, it will be m square omega square over h bar square. So I can write that here b is equal, b square means reciprocate as well, 1 over b square. Here is, if I cross multiply, then b square h bar square, so h bar square will come here, and m square omega square, and then with the h bar 4 will also come in, so m square and omega square 4 h bar square, and this implies that b comes out to be plus minus m omega over 2 h bar. If I take a square root on both sides, so it will be equal to this. Now b is supposed to be positive, so I can write that b is equal to m omega over 2 h bar. So I have found the value of b, and now I will plug in this value in h, so it will be, this h will be now a minimized one, h minimum. So this is equal to, put the value of b, m omega over 2 h bar, and then h bar square over 2m plus m omega square over 8, and 1 over b will become 2 h bar over m omega. There is some simplification, is 2 will become 4, 1 h bar is gone with this one, m is gone with this, and here m is gone with this, omega gone with this, and 2 gone with this, making it 4. So I have here the h bar omega here, and then 2 becomes 4 plus, here this is also becoming h bar omega and over 4. So 1 over 4 will come out to be 1 over 2, and h bar omega will come with it. So 1 over 2 h bar omega, and this is exactly the ground state energy of the harmonic oscillator. And this is the power of the variational principle, that the minimum energy that we got is means H earlier, it may be equal or greater than this one, but when we minimize this one, we came out to the conclusion that the energy has come out to be exactly the ground state energy of a harmonic oscillator. And with this example concludes, and we will then solve the next example on applying variational principle to find the ground state energy of a delta function potential.